multiple business units, structures, fluids, electrical, and in each business unit there are multiple different tools, and they each have their own dedicated team. Uh, we have a bunch of ninjas and experts that in each business unit will help on the support side and on the development side. So um, what we are presenting today is just the tiniest application that, based upon the people that signed up, we would like to present. Um, I encourage everyone to log into support.ansys.com, and there is on the first page there is an area that says what's new in 2024 R1, and you can find a complete slide deck, the same most of the stuff that I'm presenting here and Ashkan is presenting today. And for other tools that we have, all of those in the form of PDF exist. You all have access to it. So if you feel like you need some more information, feel free to check support.ansys.com. So on the structural business unit or mechanical business unit, there are different tools here. We have Ansys Mechanical, which most of you are familiar with. We have LS-DYNA, which is our explicit solver. It's probably the industry standard for any explicit analysis. We have Ansys Forming, which has been used for forming the sheet metal forming, and the solver for forming is LS-DYNA solver or explicit solver with the interface that is tailored towards forming applications. We have Ansys Motion, which is for MBD, multi-body dynamic analysis. You can do flex body analysis and rigid body analysis. We have Sherlock, which provides fast and accurate life predictions for electronic hardware at the component board and system level. We have Additive Solution, which focuses on additive manufacturing. We have Encode Design Lifecycle, which is, I would say, probably the best tool in the market right now for doing any fatigue analysis. If anyone has any sort of signal with different amount of loads for a period of time, they want to run fatigue analysis, Encode can do an amazing job to figure out the integrity and the endurance of your product. And we have Autodyne, which is another explicit solver and is part of Ansys Mechanical. So all these tools, they are all part of mechanical business unit. On the CFD side, we have a bunch of tools under the CFD as well. So if you would like to learn more about different application, if you have a specific application you'd like to learn, oh, how can we do this? Do I have access to it based on my current license? Feel free to send us an email. We'll be more than happy to help everyone out with your needs. First things first, one of the top highlights, basically, there is a new dark theme with 2024 R1. I highly recommend check that out. It's super easy to set that up. As of right now, Ansys provides 3 default themes. There is a dark theme, which you guys can see on the left. There is a light Ansys design language theme in the middle, and there is a classic Ansys on the right side. So it's you can also set up your own custom GUI colors and everything. You can even save it in a file or write a little script for different colors, however you want it. And every time you open Ansys, you can just import it or add it and save that default, and basically that will be your own default. Because depending on different standards that different companies have, you may like to see different graphics. So I recommend checking them out and see what may work best for you. And the way you can set that up is in your workbench. within your workbench, you can go to tools options, and then under UI options, there is a color theme. You can change that to dark and enjoy having the dark theme. I personally love it. I already set it up. It's working great. And I love the GUI. I don't think I'm going to go back. Next thing is data transfer. One of the, again, most of these topics I picked and chose based upon people's application in this call. So some of these applications may not be relevant directly to individuals, but we try to choose the information based upon the people that are going to sign up for this. So it's very, very small amount of data, but I think this is going to give you guys enough information. So after the call, you can start implementing some of these and digging deeper and learning them basically. So one of the issues that existed, I wouldn't call it issue. It's a process of integration. So Ansys acquired LS-DYNA, if I'm not making a mistake, in 2019. And ever since, Ansys has been trying to integrate LS-DYNA into mechanical and provide an integration between different types of structural solvers. And one of the things that is working much better right now is the integration between LS-DYNA and mechanical. So for example, you will set up a model and you run a static structural analysis on it. And now you want to do a couple of different things on it. So for example, you want to have the same deformed shape on the static side, and then use that to run an explicit analysis. So for example, if you have a bunch of bolts and nuts in your model, and you want to tighten all the bolts and everything on the static side, and then take it to Dyna to perform an explicit analysis, then that process of transferring data between mechanical and LS-DYNA is much smoother right now, and most of your data can be transferred easily. So I highly recommend checking that out. Based on some of the people that I see on the call right now, I know some of you guys have access to Dyna and mechanical, both of them. If you don't have access and you would like access to test a couple of things, please just let us know. We can jump in a call and help you guys to figure it out. The next interesting updates that Ansys has is memory usage improvement for large node numbering gaps. So MAPDL, mechanical APDL, memory usage was significantly decreased for models that have large number of gaps for nodes. In cases where the max defined node number is much greater than the number of defined nodes. So we have 3 examples here. You can see the column on the left side was 2023 R2. Then we have 2024 R1, and then we have 2024 R1 in core, which you can clearly see that how much memory is being used and how much improvement Ansys made for the models. So in 2023 R2, mechanical APDL needed 3 GB per process to store node information. For this example, therefore requiring enough memory that the solver went out of core and needing increased solution time. For those that are not familiar with the in-core and out-of-core, basically, if you have enough RAM on your computer, on your enough hardware, basically, then your solver will do the processing faster. If you do not have enough RAM, one of the things that can happen is the information should be written in your storage in a disk on in your computer, and that information needs to temporarily stay there so your solver can communicate between that information and your RAM and basically solve the increments to move forward. And if you don't have enough RAM, then what happens is um, Ansys needs to write some of that information in your storage. So as you can see here, the memory requirement decreased where we have large node numbering gaps, and that helps a lot with the speed of your solve. Another improvement on the memory or hardware requirement um, is memory reduction for large tabular parameters. So you can see again here, we have a before and after that the total memory usage in previous versions and current version, how much improvement we had. And this chart shows the total memory usage when solve a model contains about 6.5 gigabyte user-defined tabular parameters. So the more you have parameters in your models right now, the faster. Actually, that's not. I didn't phrase it well. If you have a lot of memory, if you have a lot of parameters in your model, it is expected your models to run much faster. Resource prediction enhancement. Another issue that we had and we have seen was resource prediction not being able to do a good job to provide accurate result in multiple different physics also. So now that has been improved. So time and memory predictions were first available in 2023 R1 and allows customers to estimate hardware resources and needed for their simulation, basically. For linear, static, and modal analysis, new for 2024 R1, disk space prediction are now available. I myself faced this issue many times that I will hit solve, I set up everything, I hit solve, and the solver will start doing its job. And somewhere in the middle of the solve, I see that my disk space is becoming full, and then the model cannot continue solving, so it aborts with an error. And you don't know, nobody knows sometimes that how much temporary files are going to be written in your storage and how much storage you are going to need to run your simulation. So for one new feature for 2024 R1 is the disk space prediction is now available. So you can check before running a harmonic analysis. In this case, it's on beta version, but that beta version is available. Just make sure also any beta version that you guys may want to use, make it activated. That needs to happen on the workbench level. I think by default, the beta features are off. And if you guys are interested to use any beta feature, you need to manually go turn it on and obviously put a lot of thought into using beta features. But as of right now, before running an analysis, if you are concerned about the disk space, you can come here and run a resource prediction, and Ansys can tell you how much temporary storage you're going to need for that specific solve. Disk space prediction. You can see that there is a new tab. Once you do that, estimates how much disk space is required. Supported for a linear, static, and modal analysis, and supported for both direct and iterative solver. So still some limitations, but it's working great. Now let's jump into another part that is more related to meshing. And one of the issues that we all have seen is where we want to do meshing and we're looking for a good quality mesh, and the size of our model is relatively big. Sometimes there are small geometry entities, like small edges or faces, that are causing a bunch of headache and are causing a bunch of issue. But at the same time, it's hard to, in a big model, to look around and find them. In this case, you can simply right click on your model and say, show minimum length edges. And you can also specify what minimum is to you. So for some people, 1 millimeter is a small. For some people, 1 inches is a small. So it could be different based upon your requirements and the dimensions and the units that you are using in your model. But in this case, it can simply tell you where that feature is. So if you would like to go merge some edges or remove some vertices and do things like that, you can basically easily find it now. Another improvement on the axisymmetric sweep meshing for improved profile mesh. You can see 2023 R2, same geometry. What was the what could have been the meshing, and now what it is. So 2024 R1, you can see that it is drastically improved the quality of the meshing. And again, what we are touch basing in half an hour needs probably multiple hours to go through all the features and improvements. In some cases, even there are some improvements behind the scene that we can't really present it in a slide deck. But what Ansys is doing on version to version is always improving capability, adding new features, enhancing certain performances, and basically making a better and more trustworthy product. We have seen in some cases, some of our customers, they come to us and they're like, oh, okay, so I ran this model in 2023 R2, and I ran the same model in 2024 R1. The results are different. We would love to sit with you guys and check the models out and make sure to talk about the differences and the changes and why that's happening. So if you see any changes between one version to another, that's because as Ansys is making those improvements, sometimes the default behind the scene is also changing. So if you see there are a lot of options. They're on program controlled, or it's on automatic. Automatic means that there is a default option selected by Ansys, and those default options sometimes changes. And if you load the same model into the newer version or even older version, because the program controlled options sometimes, in some cases, could change, then your results could change. It's not always about right or wrong. It's also about how do we interpret the results. If you would like to learn more and you are doing some version to version comparison, we'll be more than happy to sit with you and figure out what has gone wrong or what has changed so we can discuss that. And the last slide on my end to present to you guys is axisymmetric sweep support for axial multi-body connection. In some cases, when analysts are doing simulation, there are some welds or connections. For the most part, these type of connections are permanent connections. They're not like bolt and joint that they are temporary. They're spot weld, they're skip weld, they are some sort of permanent connection. If as a user, I don't care about the behavior of my weld, but I care about the behavior of my individual components and the endurance of my components and how they are behaving throughout the simulation, then I can skip going through the details. So going through the details means not modeling the welds. So if I don't want to model the wells, then I somehow needs to represent the connection between multiple components. One way is to define a specific contact between them, right? Mesh them separate, define a specific contact, like a bonded contact, and assume that they are connected, and move forward. A more accurate representation, in my opinion, is um, defining conformal nodes and defining matching nodes between different components. They may even have different material properties. It doesn't matter. This is meshing, and it goes. It cares about the nodes and the physics and stuff like that to solve them. But what happens is in those connections, one node is being shared with two different components. That's what we call it conformal nodes. In this case, the axis symmetric sweep algorithm now supports multi-body parts which share topology along the axis direction or in sections. So you can share topology, mesh them. When you mesh them, then those connections can happen much smoother and better, and can represent can do a good job representing basically your connections in real life. The answer to every FEA question starts with, or in any simulation, it starts with it depends. So if you have a model, you are working on it right now, and you're not sure what is the best approach to do simulation, please reach out to us. We'll be more than happy to help you out. With that being said, John, I'll let you talk about the next slide before I hand it over to Ashkan.
Yeah, thanks, Ali. Appreciate it. As we're transitioning from the FEA to the CFD, just a couple of comments I wanted to make. As Ali mentioned a couple times, what he presented is just a taste of what we can really dig in deeper with you. So hopefully you saw some things that you may want to get some further information on. Just reach out to your account manager or Ali directly or myself, and we can set up a separate session for you guys to get a little more information, a deeper dive on a particular subject that he presented on. A couple of other things we will be doing and sending out a survey for you guys to submit back to us, hopefully very soon, so that we can have some feedback from you and see if these types of webinars are valuable to you as far as this content, or if there's other content that you'd like to see us present on. We'd be happy to do that as well. We also are recording this session, so if you wanted to provide this to a colleague of yours as a way to get them introduced to some of the topics of 2024 R1, we'll be providing that as well. If you happen to have a question, and we are not sure if we're going to have time at the end, but if we do, just use the function in Microsoft Teams of raising your hand, and if we have time at the end, we'll get it. We will try to keep to a hard stop at noon though, and you can also, if we didn't get to your question, please just reach out to us and we'll answer them separately. And then the last thing I wanted to mention here before we go to the CFD is we are offering a training session that is open to companies. It's 40 hours of prep and delivery of training. It would be custom training on your application. It could be a project, could be a part, it could be whatever you need. It would include the Ansys Learning Hub, so you would be able to get some complimentary training from the Learning Hub with custom training from Ali or Ashkan or one of our other subject matter experts. And with this, it is not limited to the number of learners that can participate. So if you have a lot of people that are interested in the training, that's all included for $7,500. That is a limited time offer until the end of June. After that, it goes up to $10,000. So if you wanted to save $2,500 on some training and put it in your budget, between now and the end of June would be a great time to do that. All right. So that being said, I'm going to pass it over to Ashkan. So Ashkan, if you can queue up your and share your screens, that would be.
Thank you so much, John and Ali. All right, let me share my screen. Okay. All right, thank you so much, everyone, for joining this um, meeting for the highlights. I'll be talking about most of the developments in Ansys Fluent. There are many different software, safety software that Ansys provides. As you all know, we have Fluent, which is world's most powerful general CFD purpose tool. We have the CFX, which is mainly focused on turbomachinery, ChemChem Pro for chemical kinetics calculations. We have Forte, Polyflow, FinSap Ice, Rocky, and we have Thermal Desktop now as part of Ansys CFD package. There have been a lot of different highlights and updates, a lot of developments for all of these packages, softwares individually, which we really can't put in just 30 minutes. But I'm gonna just go over some of the highlights in Ansys Fluent specifically. I think it's best for everyone. And of course, at any point or after the meeting, if you have any questions or if you want to know more about specific usage or highlight mainly for your own benefit or just what you use, please let us know. We can provide more information, more slides, PDFs on the updates. But today we'll just mainly focus on some of the updates. I think these are important to know for everyone. We'll cover the GPU solver updates. There have been a lot of developments for GPU solver, which is really good for CFD purposes, can increase the speed for computations. And as we all know, GPU hardware is cheaper than CPU. So it's good for the companies as well. So we can get much faster simulations at a fraction of cost. There have been some developments in Ansys, in Python, PyFluent, and PyAnsys in general. We can use these in Fluent now, which is, again, another great tool to handle a lot of automations, and it's completely free, Python. We have some developments in combustion, which we can get into. We have some new tools for optimization, Fluent AI and machine learning, and we have general developments for different parts of the software. We have some UX UI updates and some new interesting features we'll just get into in detail. All right, we'll start with the GPU, and there have been continuous development for enhancing the GPU capabilities in Ansys Fluent. Now, in 2024 R1 supports coupled solver and segregated solver. You can change the cron number yourself. You can also have your specified pseudo-transient number if you will. And there have been a lot of different benchmark tests on Ansys side, and they are showing that, for large cases of 50 million cell, single GPU is about 11 times faster than 48 CPU cores with segregated solver, and around 9 times faster than the coupled solver. So you can see that even one GPU is much better than really high-end CPUs currently on market. Now, you can also use GPU with non-conformal interfaces and sliding mesh. Some of these features are still in beta version, but you can definitely try them out. And like the other beta versions within older updates of software, it'll be part of the legacy software and future software releases. We can use GPU right now with rotating wheels. There's a full wheel turbomachinery capability in GPU currently, and also we can use that on non-conformal interfaces and sliding mesh and mixing applications. we have developments in GPU for combustion, which is really interesting for myself personally, because the combustion is mainly what I've studied and what I do. Now we can use directly detailed chemistry, which is a large set of chemistry. It automatically computes the reaction rate algebraically, and you can have multi-species, multi-step reactions, which makes the model that you use more realistic to the actual case, because when we start with normal, like single step or very simplified reactions for different purposes, but in actuality we can use now a multi-species mechanism, which gives us, of course, better control over the reaction and more insight in general. Now we can use all of them in GPU. It's especially if you have liquid-liquid or slow reactions, such as liquid-liquid reactions or pollutant formation. We can study them all using GPU. There have been a lot of benchmark tests, make sure that the results from GPU and CPU are pretty much the same. Right now, you can use stiff chemistry solver also, which back then they couldn't do so much because it requires a lot of memory, but now the memory and performance are optimized to enable large meshes and large reaction mechanisms. So that's another development. We can also use the premix flame validations. I mean, Ansys already did a lot of testing, both for premix and non-premix or diffusion flames, normally using the industry standard Sandia flames, well studied, well documented, and for even reactions with 23 species, hundreds of reactions, these results are validated, tested, and you can, with peace of mind, use all of them in GPU, which again just increases the speed for your computations by orders of magnitude. For example, for one GPU, for a case with around 2.5 million cell, increased the speed for the computation around 10 times faster than 32 CPU cores. There's a new capability for the GPU in Ansys Fluent, which is called lightweight setup. So the beauty of it is normally when you work with larger setups with a huge mesh, as you all know, it takes a long time to just read the mesh, and setting up the case is normally like not so easy because you have to handle a large mesh, and most of us just do these setups on smaller machines before sending them to a workstation. So right now there's a new tool. It's called CPU Lightweight. So what it does is you can just easily just read the case, set up the case even on your laptop using this lightweight setup. And once you set up the case, you save it. Then on the GPU machine, you can easily open the case and then read the actual case with just like the larger mesh and continue computations without wasting so much time. And this way, Ansys had some simulations which could just reduce the time for for the loading around 5 times faster, so looking from 71 seconds loading to 13 seconds. And also another beauty of this is reducing the memory usage. So the memory usage per CPU went down from 17 gigabytes to 7 gigabytes. So again, this gives us the ability to load the cases on even laptops and set up the case over there, save it using case settings only, which is another name for the lightweight setup. And then on the GPU machine, we can just load the regular case and run the computations. There are also many beta features for the GPU. Again, for all the other highlights, there are also many beta features, which I'm not going to be able to get into all of them today in only 30 minutes. But there have been developments in discrete phase modeling. Now we can handle particle types like massless and inert in GPU. They're one-way and two-way fluid particle coupling supported in GPU. There have been updates in radiations. We can use DOM and surface-to-surface radiation models right now using GPU. There also have been updates with Python-based UDFs. I personally think these are easier than the regular old version C, C++ UDFs that we have. We can GPU easily supports Python-based UDFs right now. And as of today, Ansys Fluent is the first general CFD coding software that runs on AMD GPU. So for those of you who have AMD machines, because AMD GPUs are much cheaper than other companies, right now we can run GPU on AMD machines, but you have to just know that as of today, it's only on Linux machine. There have been a lot of testing on of all of these for DPM calculations. One GPU just resulted in 18 times faster than 128 CPU cores, which again, these high-end CPUs are much more expensive than GPUs. For AMD machines, different cases have been tested for like 50 million cells all the way to 150 million cells, and they all result in same fast simulations compared to the CPUs. When you run them on GPUs, for example, 2 GPUs resulted in 16 times faster than 128 cores. So I think these are significant. If you could just like use GPU, definitely we recommend you to do it. It's much efficient in terms of the simulation time. There have been some developments in the UI and workflow as well. There's a new tool called Fluent Web Interface, which is really interesting. I also want to use it myself. It is beta version for setup in CFD Pro, but it's actually part of the software for solution post-processing. So using Fluent Web Interface, you can open the setup from your browser anywhere. You can just connect or disconnect to the server. You can set up the case. You can pause, resume, interrupt the run. You can save the data. The residuals and have been optimized for this view. You can actually journal using Python. So it supports a lot of different features that easily you can just access through your browser on your laptop anywhere, and then do all the modifications, manipulations that you want to do with your case, and without just like loading the whole package again on your machine. So it's very convenient, easier, more efficient way to set up the cases wherever you have them. Like Ali mentioned in mechanical, now to be consistent throughout the packages that Ansys offers, dark theme is also available on Ansys Fluent and Ansys CFD packages, which I also really like. Pretty much like all of my computer software, whatever I can put, even the Office, it's in dark theme. But beside the dark theme, there have been a lot of improvements in the rendering as well. So right now you can have a much more realistic rendering compared to the older versions. For example, the ray tracing, which was introduced in 2023 R2, is still here, but there's also much more in 2024 R1. For example, you can just rotate that HD image. It can change the image, change the background. There's a live preview. The texture has been much better in 2024 R1, and you can change the lights. You can have a very good rendered picture of your result. You can put it in different environments, and pretty much it's visually for presentation purposes is much more. I think it's better. And in PyFluent, in PyAnsys in general, also there have been a lot of updates. I can get into like just some of them. Now you can use Python to just do a wide range of a wide range of different commands in Ansys Fluent. You can use it to read or write or import files, to change the mesh. You can use it for setup, just like setting up the general solvers, boundary conditions. You can change your model properties, change materials, pretty much like everything that you used to do with journals, or if you had MATLAB coupled with Fluent, if you wanted to do some automations, get the data, process the data, and then again run new simulations. So you can do all of them right now using Python and PyFluent, which again, I think the beauty of it is right now it's pretty prevalent. Everybody uses Python, and also it's free. So you don't have to have a third-party coding program to take care of the simulation needs that you used to do using, for example, MATLAB. There have been a lot of data on this as well. If you are interested in PyFluent and PyAnsys in general, please let me know. I can send you definitely a lot of information on the developments on PyAnsys and Python, PyFluent. Another exciting thing, which I personally like as well, is the AI and machine learning optimizations in Fluent. So as you may know, we had these joint-based solver optimization schemes in Fluent, which you wanted to do something, you wanted to maximize or minimize some value, some property that you defined, and automatically Fluent just goes through a range of simulations and data processing to just get that value to what you want. Now, AI is helping that. So it's actually, instead of, for example, you can use turbulence models and the Ansys Fluent will just do simulations in a way that the accuracy of the turbulence model resembles the very high fidelity models like large eddy simulations without having to do actual LES simulations, because as you know, LES is way more expensive computationally than RANS models. And generally they say it's around 100 times more in terms of time compared to the RANS model. So, but the beauty of AI is it does it for you. So just like for larger scales, automatically uses LES, and there's a new package for this. It's called Ansys Fluent AI. So it's a new license, AI Plus, which you can contact the account representative and ask for a license to try it out yourself. There has also been a lot of design tool improvements. There are new mesh morphing technologies, which pretty much compared to the benchmarks produce better, more accurate results. You have the option to solve the constraint equations using the primary morpher, and then second morpher, the second order, leads to even better results in terms of optimized solution. Sorry. And still different updates on the optimization in a joint-based solver. Again, as you knew, you can use these to change the boundaries, but right now you can also use it in chemistry. So because back then we couldn't use a joint-based solver, already had reacting flows. Right now you can use even for reacting flows. For example, in tests that they wanted to just reduce the pressure drop, at the same time increase the reaction rate, which joint-based solver does it automatically for you. You don't have to just go through the whole process of just changing manually and then trying an error. There's a beautiful new feature which is still beta, but I would still suggest you guys try it out, which is goal-based mesh adaptation. And so right now, the thing is Fluent can change the mesh for you, but it can't, but the observable is dependent on the mesh. But right now, in this new feature, the observable, the quantity that you want to optimize is independent of the mesh. You can independently change the mesh and keep the observable goal constant during the mesh refinements. This leads to a way better mesh grid, and you don't have to just refine the whole domain to just have some value optimized. It can provide a very efficient mesh. For example, in the testing that Ansys does for Wing, it resulted in 36 times smaller mesh grid, which again, that means very fast simulation and compared to the regular way. For those of you who use multiphysics, there have been new development in coupling Ansys Fluent with Ansys Maxwell. This is new, completely new, and you can use, for example, for electric switchgear arcs in gas, welding arcs, wherever you have some sort of electrical reaction, also magnetic reaction, you can have this coupled with Fluent. And I think it's very useful, especially right now that everybody uses batteries and electric cars and charges. You can definitely try it out and see for yourself. So for example, just like a circuit breaker coupled between Fluent and Ansys Maxwell. Of course, for Ansys Maxwell, you need to have another license. It's a completely different package, but nonetheless, I think it's a good development. There are a lot of developments in heat transfer. Now you can use non-uniform wall thicknesses for different purposes. You can define your own wall even using UDF. So I think it's more realistic in a lot of usages like combustion, gas turbines, electronics, which you can not assume constant wall thickness during the heat transfer process. Now you can have them actually can use the expressions to define your own non-uniform walls. And there's also a new technology for making the simulations much faster for conjugate heat transfers. Of course, this is as of now only for steady pressure based solvers, but there's a new technique called loosely coupled conjugate heat transfer, which accelerates the convergence by just clicking that in the task page. You can use this, and what it does is just like it fast and speeds up the computation, and you wouldn't have to worry about convergence as much. There's also a lot of updates in discrete phase modeling. Now you can the enhanced source term linearization and second order acute transit DPM source options. They're tested on large scale industry cases, and the results overall are much more realistic, much more improved. You can use these for dense particulate flows. There are the reacting particle frameworks, as you may know, were limited somewhat in previous versions, but right now several new reaction models are available for DPM. The reaction mechanism for urea decomposition chemistry, for example, is not part of the package, and there's a lot of validations for all of these with complex reaction mechanisms. The dynamic interaction range model, particulate larger than the cell size, is now available, which, I mean, first released in 2023 R2, but in 2024 R1. You can also use the volume displacement and two-way turbulence coupling, and include the radiation source as well. There are different enhancements in DPM as well. For example, you can have particle sampling for unsteady tracking in the injection. The workflow for one film patching improved and simplified, and also the reports that Ansys provides for DPMs are much, are also improved as well. For the DPM, across different usage, there have been improvements for Illyrian, for open channel, for Lagrangian wall film, and cavitation as well. For example, you can have your own UDF right now. You can have your own expression instead of UDF for the Illyrian. In the software, there have been new wall lubricants, wall lubrication processes, which is a beta. There have been improvements in the boiling models and post-processing of the boiling models. And overall, depending on what kind of multi-phase you want to use, open channel or even cavitation studies, overall speed, there have been some improvements in the computation speeds. And pretty much like, compared to the previous practices, previous best practices, there have been overall increase in the speed 5 to 7 times for different multi-phase problems. There has been a lot of improvements in combustion as well. And again, these are not just GPU, but overall models of combustion in Ansys CFD. Regardless of CPU or GPU to use, you can use right now thickened flame model with ChemKin CFD solver. Again, this enables you to just use model field libraries and more detailed reactions if you want to, which again results in having much more data to process, like intermediate species, and it's especially good if you want to design, for example, low pollutant combustors, for example. Now you can also look at hydrogen combustion for low NOx emissions, like we got Hylon, and there have been new developments in ammonia combustion, and of course, for premix and non-premix tests, jets, there have been a lot of new techniques, best practices for stationary and mesh, station mesh and automated mesh refinements. Pretty much, if you want to try any of these, please let us know. I can provide more information on the combustion best practices, but I think overall there have been a lot of new developments, which I personally like. Turbo machinery, I'm not going to get into details of CFX, but they're new and fluent, and you can do a lot of turbo machinery computations as well. You can have, for example, there's a new turbo machinery specific numerics, which greatly improves the convergence behavior of the turbo cases using the coupled solver. And you can just change the numeric settings, provides fast and robust convergence for turbo machinery cases. There are new improvements in the full multigrid initialization FMG, which means if you have a better initialization, you're going to have a faster steady state solution. And so, as you may all know, in the turbo machinery, initialization is key to have a good, robust computation. Solid motion mesh reference frame can be used with conjugate heat transfer cases right now for turbo machinery as well. So the conjugate heat transfer is not solved during the FMG initialization, but it'll not stop the process. So I think overall it increases the speed of the simulation as well as we're going to have a better overall convergence. There have been a lot of enhancements in the aeromechanics. You can easily map the mode shapes from mechanical to fluent. And for example, to study the blade flutter, Fluent can now export easily Excel files to use it in system coupling mapping. So that's another beautiful update, I think, from turbo machinery and Ansys Fluent. And there are a lot of different updates in blade film cooling, shroud cooling holes, for example, in transient turbine simulations. It expands Fluent's blade film cooling to model injections from the shroud in transient simulation. And overall, the radial temperature distribution across virtual cooling holes, you can do all of these right now in Ansys Fluent as well. Sorry. So like any other parts, there have been improvements in overall turbulence models, especially LES. These still beta, but I still find them interesting. There have been new techniques in LES numerics. And right now, if you use the RANs for smaller scales, WMLES, it generally combines the RANs for smaller scales and LES for larger scales. But compared to the weakly bounded central difference, the new scheme is more realistic. It doesn't create those non-physical eddies which we had back then. As you can see, for example, in the contour on the left, it's a weakly bounded central difference, but it has some weird non-physical scales of turbulence compared to the LES scheme with this WMLES. So it's a new option for Walter Edmond as well. And highly, I mean, if you use LES, if LES is not generally used in industry, but if you use LES, I would generally suggest try these new numerics, improved kinetic energy conservation, and much more realistic results in terms of the turbulence field. And also, there have been a lot of developments in the fluent meshing. Right now, there's a new multi-zone meshing, which separates the zone by face and edge during the importing the geometry. And what it does automatically is it just shows you the list of edges and faces, which you can go ahead and define the names, for example, if you want to. So you don't have to have the name selections in CAD, which is, I think, saves a lot of time. It can just, any individual face or edge could be selected and renamed in Ansys in fluent meshing. It's really, really good, especially if you would have interactive workflows, if you want to do automations, if you have parametric studies, so you can easily just read them. It automatically just separates everything. And once you have your mesh, once you have your volumetric mesh, it automatically combines all the layers. So you don't have to worry about a giant list of faces and edges in Fluent. There's a new layered thin mesh task in watertight workflow, which is still in beta. And also, it provides layered thin mesh, which is tolerant of local bulkiness. So like cases that you have some local bulkiness, for example, the e-motor air gaps or battery cells, it automatically puts some layered thin mesh. And it's overall for the, achieving a good mesh for your simulation. Still, it's beta, but it would be part of probably the package in next release of the software. And there's a new technique for meshing. It's called rapid octree meshing. So smooth mesh coarsening creates more efficient meshes. And there's another beta version, discrete mesh optimization represents the geometry more accurately. So where you have a lot of edges and especially if you have a complex geometry, it'll be able to just capture that geometry much better using the rapid octree meshing and discrete mesh optimization. There's a new feature that allows you to have multiple periodicity in single mesh. So if you have, for example, two different parts, one the periodicity of 10 degrees, and then another one, let's say 20 degrees, it allows you to have both of them in single file, which is, I think it's really interesting because you don't have to have just different meshes and different simulations. You can have everything at once. And finally, Ansys Fluent Meshing supports 2D meshing. I was really looking forward to use this because we couldn't do any 2D meshing in Fluent Meshing, but right now Fluent Mesh is able to have 2D meshing, which I think is pretty useful, especially if we do everything else in Fluent. It supports unstructured and pave with Prism, and also multi-zone structural map with Prism and edged biasing. These are just some of many features in new 2024 R1 release. I mean, I'm trying so hard to just like have these data and not to just delete what I thought is important for everyone. But trust me, if you want to know more about any of these features, or not just Fluent, but different packages as well, please let us know. Like John said, there have been a lot of different developments, and we couldn't just like you show everything just in 30 minutes. If you have any questions, please let me know, and thank you so much for listening.
All right, guys. Thank you very much. Appreciate it. We've come to the end of our time, so we're going to close this meeting for now. Be on the lookout for a follow-up email with a survey, a recording, and just let us know how we can better serve you guys. So thank you guys for participating, and we will talk to you all very soon.
Thank you.